in
Very
full screen?
super nicely, yes.
Perfect. Okay, thank you, Marianne, and thank you very much for inviting me to present at this workshop. I will be talking about the work that we are doing at the Joint Research Centre of the European Commission to model food waste along the food supply chain for different food types. So the context of this work has been already introduced by Marianne earlier. So the commitment of the EU to meet Sustainable Development Goal Target 12.3 as part of the Farm to Fork strategy, which is a key component of the European Green Deal. At the moment, the European Commission is working on setting legally binding food waste reduction targets for member states. But in order to, on a proposal to set these targets, in order to have this, to monitor progress towards achieving targets, we need to know the baseline of food waste generation. So it is in this context that a directive 851, was implemented in 2018, requiring member states to monitor the generation of food waste and to take measures to limit it. Member states needed to report by June this year food waste generated in 2020, following a common methodology and minimum quality requirements for the uniform measurement of the levels of food waste set out in Commission Delegated Decision 1597, and following a format for data reporting and submitting a quality check report. So as a result, which was implemented with the implementing decision 2000. As a result, in October earlier this year, Eurostat published the first statistics on food waste generation across the EU, which are available online. And it is in this context that at the JRC, we have been working in the last years on a model to estimate food waste generation along the supply chain based on material flow analysis by combining different sources of data, of statistical data, and different technical and scientific literature. And the aim of this model is to provide an estimation of food waste generated at EU and at member state level in order to compare and complement the amounts of food waste that are reported by member states, and also to provide a consistent overview of the evolution of food waste in order to inform possible food waste reduction targets. So the definition of food waste that is used in this model is the one set out in the Commission Delegated Decision, which is all food, including edible and inedible parts, that becomes waste. So outside the definition of food waste are unharvested crops and also animal mortality, which are not considered food. So in our model, we consider them as food losses. Also, outside the definition of food waste are all the byproducts generated at primary production and at processing that are either used for animal feed purposes or for other food or non-food uses. So this is a picture of the outcome of this model. So you can see this is the material flow analysis of the EU food system in 2018, but we have derived it also for all member states and for all years between 2000 and 2019. You can see here the different food groups that we are considering. So sugar beets, oil crops, potatoes, vegetables, fruit, cereals, meat, fish, dairy, and eggs. And that we are modeling the flows of these food groups from primary production to processing, distribution, and consumption in order to estimate the amounts of waste and byproducts that are generated at primary production and at processing, and the amounts of food waste generated at distribution and at consumption. An outcome of the model are also the consumed amount of food, which are then compared with nutritional surveys in order to perform a cross-check of the model. So from the results of our model, this is the distribution of food waste in the EU 27 in 2018. So we can see that the largest food groups contributing to food waste generated, which accounted for 82 million tons of food, are fruit and vegetables, followed by cereals, meat and potatoes, followed by the other food groups. The results of this model are available also online at this link that I've provided in some interactive dashboards that show the amounts of food waste estimated for the different member states for the time range considered, and also show the contribution of the different stages of the supply chain to the total food waste generation in the different member states. As we can see here in this chart on the right, the consumption stage is always the stage where the largest amounts of food waste are being produced. It is also possible to see in these interactive dashboards the contribution of the different food groups to the food waste generation. This varies a lot from member state to member state due to the different production and consumption patterns in the different member states. But we can see in line with what I was showing earlier for the EU as a whole, that in general, fruit and vegetables are quite predominant in most of the countries, also due to their perishability. So the methodology behind this model is illustrated in this figure. The model uses production statistics production statistics of crops and livestock products, and also trade of crops and livestock products, and production statistics and trade of manufactured products, and combines this information with coefficients taken from the scientific literature to estimate food waste at primary production, distribution, and consumption, and technical coefficients taken from different data sources to estimate food waste generation at the processing stage. This is the stage that was the hardest to model, where there is less data. And to this purpose, we have been contacting different industry associations to gather data on the production of food waste and byproducts at this stage for the different food products. So here there is a diagram showing how the model works, basically. So the starting point are production statistics on food taken from FAO commodity balance sheets that provide production, trade, and also all the different non-food uses of different crops and livestock products. From the amounts of crops and livestock products produced, we apply coefficients taken from the scientific literature to estimate food waste, food losses, and also animal feed and other byproducts generated at primary production. We then calculate for each crop and livestock product in each country the amounts that are leaving the primary production, and we estimate the quantities that are entering the manufacturing stage and the quantities that instead are distributed fresh for the food groups where this is actually taking place, for instance, fruit and vegetables and potatoes. From the amounts entering the manufacturing stage, we apply a set of coefficients to estimate the food waste generated and also the generation of byproducts to feed and to non-food. Then we use official statistics on the production and trade of processed food products to calculate the amounts entering the distribution in each country. At this stage, then we apply coefficients to estimate food waste generation at distribution, and the remaining quantities we assume that enter the consumption stage. Then we split between what is being consumed at household level and what instead is being consumed at food service level. And we apply different coefficients to estimate the food waste generation at household and at food service level. And then we have a further layer at this stage of coefficients that enable us to quantify the edible food waste generation and the inedible food waste generation. Whilst at the remaining stages, these are always considered together, edible and inedible food waste. So to give an example of one specific food group, I will show you how we modeled potatoes. So we took from FAO data on production and trade of potatoes, and then we applied coefficients taken from a scientific source, which was this report by ADEME for France, to estimate food waste, food losses, animal feed, and other byproducts at primary production. This is a limitation of the model, is the fact that we could not find coefficients to estimate food waste and losses for all the countries. So in a lot of cases, we had to rely on one or two data sources for one country and assume that similar levels of food waste are generated also in the remaining countries when using the coefficients. At the processing stage, then, we had other, let's say, other main challenges, which were, well, first of all, the fact that there is no official statistics on the amount of, for instance, in this case, potatoes distributed fresh. And also the fact that when looking at official statistics on the production of processed potato products, there were a lot of data gaps due to confidentiality. So in this case, we contacted a trade association, which is the European Potato Processors Association. And they provided us data for the main producing countries in the EU. And then we did a data gap filling exercise for the remaining countries. And with their data, we could model the amounts of potatoes used by the manufacturing stage and the amounts of processed potato products produced and the waste and byproducts generated at the manufacturing of processed potato products. And from the amounts of waste and byproducts generated, they also provided us data to estimate which share was being wasted, which share ended up being used as animal feed, and which share instead was used for non-food products, for the production of biomaterials. So, okay, so in this case, this exchanges that we had with the European Potato Processors Association was very useful to refine the modeling of this stage, and in particular to differentiate between waste and byproducts generated at this stage. So at the moment, we are working on further developing this model. Firstly, by expanding the list of food products considered, so by including also cocoa, coffee, and nuts in the modeling. We're also collecting data from more trade associations to improve the modeling of the processing stage for other food groups, and in particular from the European Fat Processors and Renderers Association in order to improve the modeling of the slaughtering stage, from the European Fruit Juice Association, and from the International Coffee Organization. As I was mentioning earlier, that a lot of the food waste and food losses coefficients that we are using are taken from the literature for a few isolated countries. We are constantly looking at new literature being published to collect more country-specific coefficients from the literature. And finally, we are exploring the use of sales data in order to improve two main steps of the model. Firstly, as I was mentioning, there is no official statistics on the amount of fresh fruit, fresh vegetables, and potatoes distributed as such in their unprocessed state. We are looking at the use of sales data to model this flow of food. And secondly, when splitting between food consumed at household and food services level, so far we have been relying on information from the literature, but this is quite scarce. So we're looking at using sales data to increase the accuracy of the model of this split between household and food service consumption for different food products and for different countries. Finally, what I've been presenting is the development of a food waste model based on material flow analysis to estimate food waste generation at EU and at member state level through time. The results of this model can be used to compare and complement the results of food waste generation that has been reported and will be reported in the next years by member states. And finally, in developing the model, we have realized that the communication with trade association has been key to refine the modeling of the processing stage, and in particular to gather data on the distinction between food waste and byproducts generation at this stage, as there is very little information in scientific literature on this. That's it. Thank you very much, and I will be happy to answer any questions.